we're gonna do some fun chemistry with foam cups, acetone, and water. So I'm gonna put on gloves and put on all my lab safety gear. Gloves are on. Lab coat is on. And safety goggles. Okay, so what we're gonna do is look at like results like in chemistry. So we're gonna be looking at polar versus non-polar and how non-polar substances are gonna be able to dissolve other non-polar substances and how polar substances would be able to dissolve polar substances. So we're gonna test this first out with foam cups. So, okay, so what I have is we have acetone, we have water. So we're gonna try with a foam cup and see what happens. So first foam cup. So first of all, something y'all should know about foam cups is, which look like this, is they can hold our hot liquids, they can hold cold liquids, but they are also considered to be non-polar substances. So let's see what happens if we put them in here. So what we're seeing is the foam cup in the water is floating and isn't dissolving. We can push it down, it pushes the water up, but nothing's happening. But the foam cup in the acetone is getting dissolved. So the reason the foam cup can get dissolved in the acetone but not in the water is because acetone is nonpolar and the foam cup is nonpolar. So we're dissolving, so remember the like dissolves like, we're dissolving two of the same substances with the same nonpolarity. Whereas a foam cup is nonpolar, water is polar, so they're not going to dissolve with each other. And we can try this again and see what happens. So there it goes, it's eating away the foam cup. And so because of this, because the foam cup is non-polar and water is polar, this is why we can put our liquid drinks, so like our water, we can put our hot water, our cold water in a foam cup and it won't dissolve. That's been dissolved. So I'm gonna show you all the foam. So there's our dissolved foam, that's what it looks like there. And so now what we can do is can stick is my finger, we're gonna push down on it. You see how it's kind of, it's almost like this mass, this gelatinous mass. And so we can push it down and play with it because of how it's reacting with the acetone. And we can even pull it out. So I'm gonna take it out. And it's kind of almost, when you take it out, it's almost like this gooey slime, and it's kind of, sort of squish it around in your hand and play with it and mess with it. But if we were to keep doing this and actually let it dry, you guys are going to be shocked at how it dries. So the dissolved foam has basically dried out on these gloves, and what we actually ended up forming was plastic. So we have formed plastic, and the reason we formed plastic is because foam cups are made out of a substance of petroleum plastic. So when we dissolve the foam cup, the dissolved material will end up solidifying as a type of plastic. And so basically what we did was we showed light dissolves light. We showed that nonpolar will dissolve nonpolar and that opposites are not going to dissolve each other. And we also showed that this foam cup, which can hold our hot chocolate, can hold our water, will actually dissolve and resolidify into plastic. We've looked at like dissolves light, so acetone will dissolve a foam cup because they are both nonpolar. But what we haven't looked at is the lab gloves that we use. So lab gloves, they're supposed to be protecting our skin from liquids that we are touching or protecting ourselves from irritants in the lab. Basically, they are for skin protection and to protect the person in the lab from what they are doing in the lab, which is really good. And so we had these lab gloves. This is a nitrile lab glove, so I use the nitrile ones, and they work with acetone. They do protect you in some degree from acetone, and acetone is just nail polish remover, so it's just like getting basically what takes off your nails is what I was dissolving foam cups in. And however, nitrile gloves are not completely resistant to acetone. So these gloves here would actually let acetone go through them. And that was true because when I was poking the dissolved foam cup around, I could feel the acetone on my fingers. And it's also why my nail polish was coming off as well, because the acetone was working on my nail polish and taking that off as well. So we're going to see what happens if we put a nitrile lab glove in acetone and see if it actually dissolves, partially dissolves, what happens with a nitrile lab glove. So let's see what happens. It's gonna be cool. Glove in here, and we're gonna see if it what happens with that. Alrighty, so let's take a look at what we have going on so far. So I am now wearing gloves because it is recommended to do so. And don't know if y'all can see that, but let me a bit. But basically there's two distinct colorations going on in the lab glove. So I'm gonna try and raise this up. So basically what we have going on is it's kind of like right here is like the cutoff point, but everywhere below my finger here has been affected by the acetone. It's kind of like a light bluishy color, and the glove's very thin and it's kind of like spread out a lot. And whereas the top part of it that really wasn't exposed to acetone is still in fairly good shape. And so there is a reason for this, and there is a reason why nitrile gloves are not great for use in acetone, is of the fact that nitrile gloves get eaten by ketones, and ketones are present in acetone. And so nitrile gloves, though they do, cover our hands and are supposed to be protecting us from liquids and stuff we use in the lab, what they don't protect us from is acetone. So acetone can still make it to the gloves through our nitrile gloves and can make it onto our skin as well. And that is because the nitrile gloves react with the ketones and start to break down. So essentially what we're doing in the acetone is we are breaking down this glove and breaking down it, and eventually we would probably be able to break it down all the way. I don't know if you guys can see this, but we have, see how it's kind of going all like wrinkly around there? So we are basically breaking down this lab glove and breaking down its components. That is just reason number whatever why chemistry is cool. So thanks for watching. Hope y'all had fun, and we can do some more experiments next time.